Alright, y'all, let's try to prove this proof. Prove that for every distinct real numbers a and b, either a plus b divided by 2 is greater than a, or a plus b divided by 2 is greater than b. Alright, I think the best way to proceed in this case is with a direct proof. Alright, so we're going to directly prove our result. Direct proof. So what we do is we start with our if part. So let's assume that a and b are real numbers, and since they're distinct, we'll say such that a does not equal b. Right? That's what it means to be distinct. All right, now let's consider this fraction. A plus b divided by 2 is either greater than a, less than a, or equal to a. All right, those are all the possible cases for a plus b divided by 2. It's either greater than a, less than a, or equal to a. That's the ordering of the real numbers. Okay, so in this first case, so let's even write up here, case 1, case 2, and case 3. All right, in case 1, if that were true, a plus b over 2 is greater than a, then we're done, right? Because we said that in all cases, or if given any, or what we were trying to show is given distinct numbers a and b, either a plus b over 2 is greater than a, or this other statement. So if a plus b over 2 is greater than a, then we're done. All right, so now let's consider, I'm actually going to jump to the third case. So case 3 is that a plus b over 2 is equal to a. So what does that give us? A plus b over 2 equals a. Well, that means that a plus b, if I multiply both sides by 2, is equal to 2a. And that means b is equal to a. And that's a problem because we required a and b to be distinct. B can't be equal to a, so this can't be true, so this can't be true. So we know that case 3 can never happen if we want a and b to be distinct. So, case 1 we're done, case 3 can't happen, so now let's consider case 2. And that is, let's write that down, case 2, a plus b over 2 is less than a. Alright, well, and because I don't have this on my board anymore, I might write a little note off to my side to remind myself where I'm going. I need to show at this point that a plus b over 2 is greater than b. Alright? So let's see what my case 2 actually gives me. If a plus b is over 2 is less than a, that means that a plus b is less than 2a, right? By multiplying both sides by 2. And that means that b is less than a, right? If I just subtract my a from both sides. Okay? Alright, well, what does that mean? Well, that means that b plus b is less than a plus b, right? If b is less than a and I add b to both sides, then I get this statement, right? Alright, so b plus b is really 2b, so 2b is less than a plus b, and what that tells me is that b is less than a plus b over 2, or what I'm really trying to show is that a plus b over 2 is bigger than b. So, let's just recap. Let's go back and look at our board. Given our assumption, a and b are real numbers such that a does not equal b, we have 3 cases. The first case, our conclusion is reached. Case 3 can't happen, and case 2, if we have case 2, we get that a plus b over 2 is greater than b. Therefore, A plus B over 2 is greater than A, or A plus B over 2 is greater than B. That completes our proof.